So we should be recording, and I'll pull this thing up, and now I should be able to write on my iPad here, and then it'll get put up on Blackboard. Okay. Now maybe you want to keep taking notes right now because I never know. All right. So we're doing problem 12. Is that right? 11. Okay. Problem 11. Okay, if a particle has an initial velocity of 12 to the right when s equals 0, determine its position when t equals 10 if acceleration is 2 to the left. Okay, so we're going to choose an origin. Where do you want to choose an origin? At at s equals 0? Okay, so we'll put a point here and we'll say, okay, that's s equals 0. That's your origin, right? And then particle moves, let's see, particle is initial velocity, so V0 equals 12. V0 equals 12. And he's to the right, so we'll give it positive. Let's see, determine the position when t equals 10 if A is 2 to the left. Okay, so what is A? Positive or negative? Negative. Okay, so the acceleration is a -2. Okay, so we want to know position, given position, we're given velocity, we're given time, we're given A. What equation should I use? Very good. You're not going to remember this because you can bring in one page of GP, right? And I know bring in your laptop, you're going to have a PDF file. Don't do that. If I catch you doing that, bring in one sheet, right? So you won't have to memorize that. Okay, but anyway, we're going to use the x equals x0 plus, right? So let's put that one down. So s equals s0 plus v0t plus 1/2 a t squared, right? So let's plug in. So s, which is what I want, equals s0. What's s0? Why? Because you chose the origin there, right? So that's 0. What's the initial velocity? 12 plus or minus? Why plus? Yeah, because that's what we chose to be the positive direction. So we'll put in plus 12. The time they told me was 10. Is that right? Yeah, okay. Times 10. Let's see, plus 1/2 a. What is a? -2. So I'll say minus 1/2 times 2 times 10 squared. Okay, so got your calculator, bing, bang, boom, off you go. So it's 100, let's see, -100, 120 minus 120. Okay, so S is 20. Does that answer your question? Okay. Can you give me an answer? What was causing the direction? The directions and the equation, because you didn't know when it's negative where to plug it. Is that the idea? Sure. Let me address his problem. Seeing this plus or minus, here's what I whenever I write the equation down, put a little pop x equals 0 plus v0t plus 1/2 at squared. I just copy them down. Then when I number, so like for example, if 0 is negative number, I put it in, right? So what I would I do this. I'd say, all right, let's take this equation right here, right? This one here, okay? And I'll show you what I mean. I write it down like it comes out of the book with all pluses, and then I would come in and I'd say s equals, okay, and then 0, and then if this 12 to the left, if it was to the left, I would say plus, because that's what the equation is, and then I'd do the parentheses minus 11 or 12 or whatever it is. Get the idea? So when you get confused with the pluses and minuses, do that. You're not confused. It's just fine. You're good. Keep going, right? But if you get confused about that negative, keep everything straight off, and then parentheses. Everything in the equation is way came straight off, and then put parentheses, and then put your negative in there. Okay. Okay. And that might help you. Okay. Okay. You wanted me to do the next one. All right. Okay. Next one is number 12. Determine the time required for a car to travel 1 kilometer. Determine the time required. Let's see. Time required. Travel 1 kilometer down road. Car starts from rest, reaches a maximum speed at some intermediate point, and then stops at the end of the road. The car can accelerate at 1.5 and accelerate at 2. Okay. So what's going to happen is he's sitting still. You hit the gas. He's going to take off. He's going to hit a maximum speed or something. Is that right? Reaches a maximum speed, and then he stops at the road. Okay, so he's gonna do something like this. So it's acceleration to start off. This will be acceleration this time. So he's going to start off with a maximum acceleration, and at some point he's going to slam the brakes on. Right? Is it going to look like that? Everybody agree? Okay. This is not a constant acceleration across that, right? It's constant from this point here over to this point here. I'm not sure you can, right? It's constant from here to there, and then it's constant from here to here. So how do you do problems like that? I've done them before. You break them up. So what you do is you say, okay, I'll use the equations for the areas where it's constant. Okay? And so here's what we'll say, okay, let's define this point 1. This guy right here is point 1. And we'll say this point right here is point 2. Is that okay? All right, now let's write some equations. I'm interested in position. Right? So let me write the position. So x at point 1 equals what? Okay, this is, I'm asking you to memorize that equation. It's equal to what? At this point, do you know that's how far he is? That would be over here at 2. Right? So x at 1, think about the equation. X equals x0, x0, good. What's x0? 0. Okay, x1 equals 0 plus, what's the initial velocity? Yeah, 0, right? So I'm just plugging into the equation. Plus 0 times time plus 1/2. What's the acceleration? 1.5. And it's positive, right? Times time squared. There we go. Maybe I can solve this. How many variables? 2 variables? How many equations? Okay, so I'm not done yet. So don't panic. Okay, I'm not done yet. Some more equations, right? Okay, let's see. Told me the x at 2. That's what y'all are saying. 1.5 kilometers, right? Okay. Okay. Whatever it is. Okay. So let's use that information. They told it to me, right? So x at 2 is how much? 1 kilometer. Okay. So x at 2 would be 1 kilometer, and that we're going to put it in meters, right? So if you don't want to worry about it, put them in meters, seconds, newtons, kilograms, and then don't worry about units. Okay. So 1,000 meters equals. Okay. So where did he start? At x1. Okay. So he starts at x1. What's the initial velocity? v1. Okay. Good. So I say, okay, plus v1 times time. Is it t minus something? T minus. Okay, so what should I subtract here? I should put one. T1. T minus T1. Maybe I should put here. T2 minus T1. Okay. Okay.
I should make a 2 here. T2
What's
minus
the
T1.
acceleration?
Is that clear?
Negative. It's deceleration. What is
What's the
deceleration?
acceleration now?
It's always to the left, right?
Negative. He's decelerating.
Always to the
What
right.
do they mean by decelerating? It's always to the left, right?
It's opposite your motion.
Always to the right.
When you decelerate, whichever way you're headed, you're slowing down. That's what deceleration means. They often use deceleration for both. Okay? So it'd be like saying we're all human.
Deceleration for both.
Some of us are men, right? So that's the difference. It's all acceleration. Some accelerations are decelerations because they're slowing you down. Okay? So you have to cover that. Okay. So that would be negative, right? Minus 1/2.
So you have to cover that. Okay.
And what's the
So that would be
deceleration?
negative, right? Minus 1/2.
2?
And what's the deceleration?
Yeah, you're right. 2 times T1, T2 minus T1 squared.
Times T1, T2
Huh?
minus T1
Oh,
squared.
yeah, right.
Huh?
There, is that better?
Huh.
Okay, good.
Yeah, right.
All right. How many unknowns? X1, T1, T2, V1. Man, it's getting worse.
T1, T2, V1.
V1. Okay. Is that what you said? V1? All right, so let's do a V1. V1
Okay.
equals
Is that what you said?
what?
V1? All right, so let's do a V1.
Initial? Is that 0?
What?
Plus the acceleration is
Initial?
1.5
0?
times T1.
Plus the acceleration is 1.5.
Okay. Nothing. No.
Times
Still have
T1.
X1, T1,
Okay. Nothing. No new
V1,
unknowns, right?
T2.
So I still have 4 unknowns.
and I have
X1,
equation.
T1.
Still missing something. What am I missing?
V1, T2. And I have 3 equations. Still missing. What am I missing?
What is velocity? 0. Ha! Here we go. So you see what I'm
What
trying
is the
to
final velocity?
do? If you don't know,
0. Aha.
often
we go. So you can see what
somebody
I'm trying to do. If you don't know what you're doing,
never worked.
oftentimes that's the case. You know,
Okay.
somebody gives
So,
me a problem, right? They come into the office. Oh, I've never worked that problem before. Okay. So instead of panicking, I just start writing the equations.
Say,
Boop, 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 boop,
how many
and I'm counting how many unknowns I have
kind of
there.
do this?
Or
I want to look
same thing.
intelligent.
How many
Then
unknowns and how many
if they're not matching, I'll turn it back to the suit and say, well,
and then
they don't match. Something else. What's given, right? And then they go, oh no, this. Well, how do you know there's something given? Because they got to match, right? Now, if you were working for some company and you called me to consult for you, I don't know if you have a well-defined problem. Your problem may not be solvable, right? So we'll have to get into it. But these problems, they're solvable. I have too many unknowns. There is something that we overlooked. And what was it? Oh, it has to stop at the end. Okay, got it. V2 has to be 0. Okay, so I'm going to write that one. V2, 0 equals. What's the initial velocity?
Okay, so I'm going to write that one.
V1.
V2, 0 equals.
He's decelerating. So he's going to be a negative 2. What's the time?
So he's going to
T2 minus T1.
What's the time?
Now how
Minus
many unknowns
T1.
do we have? 4 equations. 4. Could it be solved now?
Now how
Yes. Do you want to use mathematics?
Okay. Could it be solved now? Use mathematics.
Okay, I've got Mathematica up here somewhere. There we go.
Okay, I've got mathematics up here somewhere.
And let me enlarge it so you can see it. Okay, one of the things I like
And enlarge
with,
it so you can see it.
because mathematics remembers everything from the time it started, okay, until you quit, right? So, you know, if you're doing your homework and all of a sudden you get garbage coming out, you go, what? Do a quit and try. Okay. So anyway, we quit. Now what do we do?
What? Do it, quit, and then try
Type
again.
in the equations.
Okay. So anyway,
Okay,
we
so I'm
quit.
going to say
So now
equation, EQN. You can name it anything you want, right? I'm a creature of habit. I like to do things the same way each time. Okay, here we go. X1. Yes.
When you put a EQN, do you have to put the two?
No, no. If you want to name it,
So for example, whenever I say EQN is the name of all of these equations, I use one equal sign. When I say this is equal to this, please solve it, I need two. So I would have done it backwards, right? Because you always write equations. But anyway, so one says, I want to just give it a name so I can refer to it. Okay.
so if you want to name it, you use one. If you want it equal, you use two. So X1 equals uh, 0.5 times, and I just do a little space, 1.5 space T1 squared. Is that good? And I didn't put the X's in there. It comes in. I just put a space, and it kind of fills it in. Yeah.
Is this included in your recording?
I think it is. Okay, so you all got to let me know that I screwed up or not. But I believe the iPad is catching my voice. Okay, and the screen, the whole screen is being recorded. That's what I think. Okay, but you might want to take notes just in case. Okay, all right. And we have a YouTube channel set up. As soon as they teach me about that, oh my God, you know. Anyway, so okay, there's the first equation, and then I like to align them kind of separate. 1,000 equals x1 plus v1 parentheses. So you don't need the times, right? If it's obvious that it's going to be multiplied, you don't need to put them in it. If you're in doubt, throw them in. Put in a capital E with a little star, right? Whatever. But it'll take it this way. V1 times parentheses T2 minus T1 close minus 1.5 space 2 parentheses T2 minus T1 close parentheses squared. So far, okay?
You text two N's.
Oh, you're right. Thank you. That would have given me crazy answers. You know, I some time ago, I mean, I really was up on technology, and when we were using technology to teach with, we found that it was a lot easier if you're going to do your homework and things of that sort. You know, on a test, you got to do it alone. But if you were going to do homework, it was always beneficial to have people, right? Everybody, one person would do the typing, the second person would read the typing, catch things like that. Okay, and it very effective at in increasing your efficiency. Okay, but you know, don't always have the same person type, right? So Monday you type, Tuesday the other person types, so that you get used to it. But you got that other set of eyes to say, no, 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 you made a mistake here, right? Because it's so easy to do. Okay, let's see, and then the next equation. Whoops, what did I do? Okay, the next equation is V1 equals 1 5 times T1. And then the final one, 0 equals V1 minus 2 parentheses T2 minus T1. Close parentheses, close wiggle bracket because it's a set of stuff. Okay, and then I hit enter, and it repeats to me what the equations are. And so I like to kind of look at this and go, yeah, I think that's it, right? And then what do? Solve them. Okay, so I say capital SOLVE, square bracket, and then I say, here are the equations, EQN. Remember, there's one equal sign on the EQN. That's why it's named EQN.
After the, if you change the equation, which has to be pressed after the. Oh,
to make it execute on, if you don't have a numeric keypad, they'll have a keypad, right? So I hit this one over here on the keypad. If you don't have a keypad, you hold down shift, any shift, hit the enter, if that's all you have. Shift, hit enter. Okay, and then it will. Okay, if you're going to use Mathematica on the exam, then you should be bringing your laptops to class and practice, because what'll happen is you'll forget a comma, you forget something under the stress of the exam, and then you'll go nuts. All right, so you want to experience and get good at it. So if you're going to use it, bring the laptop. Okay. So you say, I want to solve those, and then you have to tell it what you're going to solve for. I have 4 equations, so I have to give you 4 things to solve for. What are they? X1, X, T1, T2, V1. And there you go. Okay. How many answers are there? Right. Yeah, there's 2. See here, between here and here, and between here and here. So which one do you think? Yeah, second one, the one with the positive times. Okay. How's that? Anything else you want to say after the second? Okay. The next thing is very similar, but we're going to be using different coordinates. Okay. These are called tangent and normal and cylindrical. Let me save this math file before I screw something up. This is September 8th. Incidentally, if you notice here, it's saying that Solve was unable to do it with the inexact coefficients. What it does is it converts, whenever you have a decimal point in any one of those numbers, it will try to do it with inexact arithmetic. If you take out all the decimals, like for example, 0.75, write it as 3/4. You don't have to, but if you did, then what you'll do is you get an answer that is out, exact mathematics. They'll use fractions, and it's really pretty neat. But engineers always like decimal, right? So anyway, that's what math. Okay, so here we go. Going into the next section, this homework assignment is due, I think, next Monday or Tuesday. So you'll have a weekend to do what I'm talking about now. Okay. Uh, you have been using X, which normally we think X is horizontal, Y vertical. It doesn't have to be, but the 2 directions, straight directions. There are other ways to define velocities and acceleration. One of them is tangent normal. And in order to do tangent normal, what you have to know is you've got to know the path that you're on. Okay, so in this book, normally, so you know it's on the circle. And the tangent normal direction is just like the I normally you think is horizontal, the J normally you think is vertical. In this particular case, you have a tangent direction and you have a normal direction. The way you find it is you've got to have the path. If you don't have the path, you cannot use this formula. Okay? So if you have the path, I'm right here on the path, you draw a tangent line to the path. And there are mathematical definitions for tangents, right? So if you have the mathematical formula for that path, you can take a derivative of the formula, and that the tangent. If you don't, for example, if you're just kind of working graphic, maybe you've got a block, then what you do is you lay straight edge there, there's your tangent, okay? But you've got to find the tangent. This direction is called the tangent direction, and I think the book uses a U, UT. That's the tangent
This
direction.
direction is called the tangent direction. and I
The
use
second
use
direction is
U,
perpendicular to this.
UT.
Okay, 90 degrees off.
That's the
So what
tangent.
you do is after you find the T,
The
you
second
draw a
direction is
perpendicular line.
perpendicular to this. Okay, 90 degrees
And the
off of this.
normal
So what you do
direction
is
is
after
along
you
that
find
line.
UT,
The normal
draw a
direction
perpendicular
always
line.
points inward on the curve.
And the normal
Okay, so what's the
direction
inward
is
side?
along that line.
Is it up here?
The normal direction always
Is this the inward? Or is
points
this the
inward
inward?
on the curve.
How do you know?
Okay, so what's the inward side?
Yeah, you
Up
have to
here?
look at the curve, right? So this guy
Is
is
this the inward or is this the
like a
inward?
bowl. So this guy
How do you
right
know?
here is the inward side. See that?
You have to
It's not
look at
too
the
hard,
curve,
right?
right?
Okay,
This
so
guy is kind of
the
curved like a bowl.
so then you the
So this guy right
arrow
here is the
here, and you
inward
say
side.
this is U
See that?
U N.
Okay, so that would be the normal direction.
Okay, so that's
then
the
you put an
tangent.
arrow here and you say this is
Okay. The formulas that you have is velocity.
okay. That's the tangent.
It's a vector. Is always equal to the
The
speed.
formulas that you
Your
have
book
is
uses a little
velocity
lowercase v. It's the speed in the UT direction.
is always equal to the speed.
So in other words, the velocity
v,
always
what's the speed
tangent to the path.
in the UT direction.
Always tangent to the path. Okay.
So in other words, your velocity is always tangent to the path. Always tangent
The
to
speed is equal to the time rate of change of the distance along the path. So for example, a circle,
the
right?
speed
You know the distance around the
is equal
circle.
to the time
So if you
rate
know
of
the
change of
diameter,
distance
radius of
along
the
the
circle, you find the
path. So for
distance
example,
around.
a circle, right?
Okay.
You know
The
the
speed that
distance
that
around the
distance
circle.
changes
So if
is
you
your
know the diameter, radius,
the dd.
find the
Okay.
distance around.
What is the V?
The speed
The little v is
changes
speed.
your speed.
So that'd be like your speedometer.
DD.
So this is the way you're doing things in the car, right? You're on the road, you're on I,
Speed.
you know where I
So that'd
is
be
going,
like
bends, weaves, whatever,
okay,
and you've got a
things in the
speedometer
car, right?
that says you're doing
You're on the
110.
road, you're on
All right, so that's your
you know
speed
where
down that thing.
going.
Your velocity is always tangent unless you run off the
Got a
road. It's always
speedometer
tangent to the path. Okay.
That's speed down.
The acceleration
Always tangent unless you run off.
has two parts. One part is the change in speed. So if you have your foot on the gas, foot on the brake,
Has two parts.
you're going to change your speed. Get the idea?
Part
And the direction of that is in the tangent direction.
the gas or foot on the brake. You're going to change your speed.
The second component is
And the
speed
direction of
squared
that is in the tangent direction.
over radius of curvature in the in direction.
Second component is speed squared over radius of curvature.
This is this one here? That is a U. It's the unit vector in the tangent direction. Which is what? V is the speed. This is the change in speed. So you got your foot on the gas, speeding up. Your foot on the brake, you're slowing down. V. Oh, this is the radius of curvature. They always write it as R. I think they just try to speed. Radius of curvature. What would be the radius of curvature on a circle with a diameter of 4? 2. Radius of curvature on a circle is the radius. Also, curves have radius of curvature. Is it easy to find? No. In calculus, probably they have this really weird, crazy formula: dy dx squared. Remember anything like that? Man, that's how they calculate the radius of curvature of weird curves. Okay, if you can't find the radius of curvature, there's no point using this formula. You got to have it. Okay, there are problems where I could give you the acceleration and ask you what the radius of curvature is. I can do that, right? But you got to be able to get it. And most problems they'll be circles. Thank goodness, right? Any questions so far? Nope. That's it.
What is it?
Don't use unit vectors. So there's UT and a UN. Yeah. And normal, tangent, normal. Okay. And the way you find them is you have to know the path. Right, so either somebody draws it for you, or they say it's a circle or something. Gotta have a path. And the first thing you do is draw a tangent line, and that gets you your UT. Once you know where that is, then you can go 90 degrees and get the UN. Never get the UN and the T. Always the T, then the UN. Okay? All right, you want a problem?
Yes.
Okay.
How about it's problem 118? How about it's problem 118? One 118. Truck travels in a circular path. Let me see if I make it a little bigger. Man, I'm getting good at this. Scary thought. The truck travels in a circular path having a radius of 50 at a speed of 4. For a short distance from S equals 0, its speed is increased by B dot equals blah, 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 S, where S is meters. Determine its speed and the magnitude of its acceleration when it has moved S equals 10. Oh, man. Determine its speed and the magnitude. What are we going to do? What do you want to do? Okay, radius of 50. They tell me the radius of curvature. Thank goodness, right? So I got that. They say that it has a speed of 4 at some point. See? Like right up here at the top, he's got a speed of 4. And what does that V dot mean? Yes, a change in speed, change in V, right? So the V is changing by 0.05 S. And so what I want to know is what's going to be the V when I'm interested in it. I know it's 4 there, but when S equals 10, what's the speed going to be? How am I going to find that? I think I heard from somebody. I'm going to integrate just like I did all these others, right? If I have dV dt, that right? V dot V dt equals the S. Okay? So how am I going to integrate this thing? So how am I going to integrate this thing? Well, let's give it a shot. You know what I'm trying to do, though, right? I need to find the V when S equals 10. Right? And we've done that before. That's how we got those equations, fancy equations. When acceleration is constant, we separate the variables, we integrate, right? That's what I'm going to do. You ready? Yes. Okay. You're going to have to help me because I'm not that good at it. You ready? It gives you a confidence, doesn't it? Say, man, oh. Okay. So V dot, okay. dV dt. That's V dot equals. Okay, so V dot, okay. 0.05 0.05 S. Okay. Now, what do you do? This is a differential equation. Scary, but it's a differential equation. And how do we solve it? Okay. Now, what do you do? This is a differential equation. Don't mean to scare you. Can I? But it's a differential equation. And how do we solve differential equations in this class? Separate the variables. I put the dt over on the right hand side. Separate the variables in this? I've got the dv separated. It's the only v. Right? dv. What do you got on the side? I put dt over on the right hand side. You can't integrate You could integrate SDS, you can integrate TDP, right? You can't integrate SDT. You don't know how SDT. Stuck, huh? Well, you remember that formula I gave you when we were writing one of the equations? It was D dV dt, no, D dV dx equals acceleration. You remember that? How did I get that? You don't remember? That's exactly right. Yeah. So here's what I want to do. I want to start off with this dV, but you see what the problem is up here? I can't, we can't see it. Problem right there? I can't separate the variables. So I have to do something else. So here's what I'm going to write. dV, and then I'm going to write SDS equals 0.05 S. Okay. And I'm going to switch DT and the DS at the bottom. Mathematicians hate this. They say, oh, whatever. dV, DS, DST equals 0.05 S. What's DST? That's the velocity or the speed, right? So this would be dV ds times E equals 0.05. Now separate. Okay, separate the variables and integrate. Don't peek. You do it. Okay, separate the variables and integrate it. Don't peek at me. You do it. See if that's what you got. Yeah. See if that's what you got. Okay. The this guy right here, I just threw in the DS over DS. That's one. Okay. Then what I did is I took this piece and this one, and I just moved them side, switched. And so that's a DVDS and a DST right here. And that is the derivative of the position, which is velocity. DS. So far, so good. Okay. So can you find the speed, velocity, when S equals 10? What is it? So far, so good. Okay. So can you find the speed, velocity, when S equals 10? Can you find speed when S equals 10? How? Can you find? You can find the C. How am I going to find the C? Good. So when position equals zero, the speed. How am I going to find the C? Right. So when the speed is equal to zero, excuse me, S is equal to zero, speed is equal to 4. So let's see. I'm going to put it in up here. 1/2. 4 squared is 16 equals 0 plus C. So C is equal to 8. Okay, now tell me the speed at S equals 10. That'd be 100 over 2 is 50. 50 times 0.05 be 5 times 2.5, right? Yeah,
50. 50
sure,
times
maybe
0.5.
this screen. You get it?
2.5.
Okay.
Right. Yeah.
So 2.5 plus
Maybe
8, 10.5.
this screen. You get it?
Is that right?
So 2.5
I'm
plus
just plugging numbers.
10.5.
It's what?
Right.
Ooh, yeah. Boy, stupid. Okay. Yeah, all right. I don't have a calculator. Can you
It's what?
punch it in? Let's see, that'd be 2.5
Ooh, yeah.
times 2 is 5, square root of 5. Is that what you're telling
Yeah.
me?
All right. I don't have a calculator. Can you punch it in?
Okay,
Let's
S
see,
is
that'd be
10, so I'm going to put a 10 in here. So
times
that's 100.
2 is 5.
That's 5
Square
over
root of 5.
is
Is that what
2.5.
you're telling me?
2.5 plus 8 is 10.5. Square root, oh,
S is 10,
10.5,
so I'm going to put a 10 in here.
21,
That's 100.
square root of
So
21,
that's 5 over 2 is
right?
2.5.
Okay,
2.5
so
plus 8
speed
is 10.5.
is square root of 21.
10.5, 21, square
Just
root of
plug in
21.
numbers in.
Right? Okay.
Yeah.
So the speed is square root of 21.
Here?
Just plug in numbers.
Oh,
Yeah.
the speed was 4. 1/2 times speed is 4. S is 0.
It's given in the problem, right? The problem says right up here, S equals 0, the speed is 4.
It's given in the problem. Right. Problem says right up here. S equals
Not
0,
yet,
speed is 4.
right? So now I have the speed, and what it wants to know is what's the magnitude of the acceleration. Magnitude of acceleration. So I'm going to find the acceleration, then I'm going to find the
Now I have the
magnitude.
speed. And what it wants
Okay,
to know is what's the magnitude
you ready?
of the acceleration.
So what's the acceleration? Give me a
So I'm gonna
formula
find
for
the speed,
acceleration.
then I'm going to find the magnitude.
Yep. And I'm not in 9J.
You ready?
I'm in tangent normal.
So what's the
What was the
acceleration?
formula for
Formula for
acceleration?
acceleration.
Acceleration
And I'm not 9J.
was equal
I'm
to
in tangent normal.
v dot
What was the formula
in the
for
tangent direction
acceleration? Acceleration
plus what?
is equal
Speed
to
squared.
v dot in the
Ah,
tangent direction
come on. Doesn't want to take my square.
plus what?
Divided by
Speed
radius of
squared.
curvature in the normal.
Ah, come on. Doesn't want to take the square.
Okay. So let's
Divided
plug
by
in
radius of curvature in the
acceleration.
normal.
What's v dot? 0.05.
Okay. So plug in
What's S?
acceleration. What's v
Right
dot?
now it's 10, right? So that would be 0.5, right?
0.05 s.
0.5
What's s?
in the
Right now
UT
it's 10, right? So that would be 0.5.
plus. What's the speed? We just calculated. Square
0.5
root of 21. Square that,
in the UT
21.
plus. What's the speed? Just calculate it.
Radius of curvature, they said
Square root of
was 50.
Square that. 21. Radius of
There we go.
curvature, they said
How do you find
was
magnitude?
50.
Right,
There you
it's
go.
the Pythagorean theorem, right?
Find magnitude.
So you take the square of each leg, square root. So what this is the magnitude of acceleration
Right. It's Pythagorean theorem.
is equal to
So you take the
square root
leg, square root.
0.5
What this is the
squared
magnitude of acceleration
plus 21 over 50
is equal to
squared.
square root 0.5 squared plus
Okay, so let's back up and review.
21 over 50
What did you do for this problem?
squared.
What do we have to do? They said one acceleration. So I've
Okay,
got
so
to find the
let's back up.
acceleration equation,
What
right?
did you do to do this
How do
problem?
I know to use tangent and normal instead of I and J?
They said they want
Yeah, you have a question.
acceleration, so I've got to find an acceleration equation.
It is
How did I
21
know
because
to use tangent
let me look back here.
instead of I?
Okay,
Yeah, it was just it's the square of the velocity. Yeah.
It is
How
21
do I know it
because
was tangent normal and not IJ? Because you're going to have to take an exam from me, right?
it's the square of the
And I'm not going to say, okay, use tangent normal here.
How did
Why?
I know it was
Why
tangent
would you
normal,
look
it's
at
not
this
I?
problem and say this is definitely, and don't say it comes out of section 4.
And
That
I'm
would
not
help
going
me.
to say,
Okay.
okay, use tangent
How would
normal.
you say that this is a tangent
Why
normal?
would you look at this problem and say this is definitely, and don't
Okay,
say it's coming
circular
out of
path.
section
If you did
4.
not
That
know
won't
the
help
path,
you.
you can get
How
doing
would you
tangent
say
normal.
that
That's a
this is
dead
a
fire sure
tangent?
thing. And it's path, forget it.
Okay,
It's like
circular path. If you did not
know what
know the
path
path,
it's on?
you can
Nope. Then would you use tangent normal? Nope.
don't know
Right?
the path.
Because you got to know the path.
So that's a dead giveaway. Now I can do weird things to you, right? And I can say, uh, uh, and it's just
I can do weird things to you.
that.
And I can say, yeah, this guy is
What else?
a truck and he's
What
got a
else?
circular
Here,
path and it's
special.
not the tangent.
What were the other
Just
things
because I
given
gave you the path,
that
does that
changes?
necessarily mean
Okay,
it's
the
tangent
speed is
normal?
changing,
What
the
else?
amount, right?
What else?
Those things are that formula.
What were
Tangent
the
normal.
other things that were
Speed
given?
changes. What else? The velocity.
Okay, the speed
I
is
gave you
changing by
well
the
the
amount,
speed.
right?
Give you the
Those
speed.
things are in
Giving you the path. I'm giving you the change in the speed, and I'm asking you for velocity. You see those things? Those are the keys that when you read the problem, you say, aha, this is going to be one of those tangent normal things. You got it? Okay, so on an exam, you can spot it. Okay, so on the next clear question, I might come in here and have you ask you a question and say, is this or is this not a tangent normal? And you'll pass it, right? Good. Okay. Let me do the next one. How much time do we have? Oh, 5 minutes. Okay. Well, let's see. Let's do another tangent normal then.
The next one. How much time do we have? Oh, 5 minutes. Okay.
How about 131?
Well, let's see. Let's do another tangent normal.
Yeah.
How about 131?
I think so. I thought it was it, what was the V dot? Oh, yeah, because it was V dot was 0.05 times S, and S was 10. Okay, I'm going to go to 131.
Okay, I'm going to go to 131.
Okay, let's see. At a given instant, the engine at E has a speed of 20 and an acceleration of 14, acting in the direction shown. Determine the rate of increase in the train's speed and the radius of curvature of the path. Why is this going to be tangent? Okay, rate of increase. I haven't seen that in any of the other formulas. I want the acceleration. I want radius of curvature. Can you spot those things and go, aha? Even though you know it is, it's definitely the second. But on the test, you do those things and say, ah, he's not going to, right? Okay, so say it's a, am I going to do it? Tangent normal. Am I going to, how am I going to get the radius of curvature?
So, how am I going to do it? Tangent north? How am I going to do it? How am I going to
Huh? Okay. Do you have a formula for the radius of curvature? Okay. So there was an acceleration term, and there was a change in speed, u tangent, plus speed squared over radius of curvature, u normal. So you find the normal acceleration? How big is the normal acceleration? How would you find that? Huh? Is it given? Is it this 14 guy right here? Is that the normal? Where does the normal point? Inward. That's pointing inward. Perpendicular to what? From the tangent, right? I told you first you find the tangent. You don't ever go in there and look for the in, right? You don't look for the normal first. You look for the tangent. Where's the tangent? You do. Yes, you're ahead of me. Yes. Okay, this is tangent direction right here. You see that d equal 20? The velocity is always tangent to the path. Okay, so draw a line perpendicular to that. It's drawn on the book. Can you see it? It's this guy right here. This thing right there. See that line? That's perpendicular to the speed. See that? Okay, so I want the amount of acceleration along that line. How do I get it? I want the amount of this that's along that line. That's the normal amount. You see that? So how do I get this? 14 times what? Cosine of well, where's that angle measured from? No, 75 is from here. It's the sine of 75. Got it? Or cosine. Yeah. Okay. Right. Right. You can do. So it would be 14 sine of 75 is the normal acceleration, and that equals speed. What was the speed? 20. 20 squared divided by radius of curvature. Can you solve this? Okay. Then what else do you want me to do? Determine the rate of increase in the rate of speed. You want v dot. How do you find v dot? You see this term right here? What is the tangent component of acceleration? The tangent component of acceleration. You see this term right here? 14. What is the tangent? Right, you want this acceleration. Cosine. See that? 14 cosine times 14 cosine 75 equals v dot. Is it speeding up or slowing down? Speeding up. His velocity is going this way. This is acceleration. Is it speeding up or same way? It's going faster, 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 faster. That's my 2 minutes. What else do you want to talk about? Last minute questions? What is the normal? What else do you want to talk about? And we already got any last minute questions? The normal is right here. Yes, 14 sine 75 is the normal acceleration. 14 is acceleration. This one here? Yeah. Hello. No. UN? Yeah. Okay, this is the tangent acceleration. Okay, that's the normal acceleration. Okay. Because he's that much in that direction.